Okay. So our new unit we're going to be talking about, okay, is still going to be talking mostly about triangles. Okay, we're still going to be mostly focused on triangles. Okay, and specifically right triangles. Okay, specifically right triangles. But today we're actually going to start looking at some right triangles and things like that too. So today we're going to be talking about simplifying square roots. Okay, simplifying square roots and solving right triangles. We're going to kind of do two things at once. Now, hopefully, did you guys simplify square roots in Algebra 1? A million years ago, right? All right. I believe that's a topic in Algebra 1. Ms. Bachman, I don't know. I mean, yes, that's something. I haven't actually taught that new Common Core Algebra 1 curriculum, so I don't know. But I believe it is a topic. Okay? So, first of all, we have to remember here what a square root kind of means, right? So when we so... All right. All right. So square root of 16. Okay. What does that equal?
4 times 4.
4. Okay. How do you know that? 4 times 4 equals 16. Okay, right. Because 4 times 4 is equal to 16. So zoom in a little bit. Absolutely. Bless you. Is that good? Yep. So that equals 4. That's right. Okay. Let's see here. If we have... Okay, let me just change it up a little bit here. Let's say we want to solve for x. And let's say that I have that x squared is equal to 121. Okay. So, yes, x can equal 11. Okay, but again, to solve this equation, what do we do? How do you solve this equation? I mean, Debbie knows the answer, but what's the work we want to do here? Remember, we want to solve for x. How can I get x by itself, Mitch?
It's kind of, I just gotta say that can it also be like negative 11?
So we'll get to that. Yes, that's right. But what do we do here to kind of both sides simplify this? Let's go to Eli. Square root, right? So that's what this symbol means, okay? Square root and square, they're opposites. They're inverses of each other. Just like when you see an equation and you have addition in the equation, what do you do to undo addition? Subtraction, right? When you see subtraction, what do you do to undo subtraction? Addition, right? And then multiplication and division, they are also inverses. They cancel each other out. Therefore, or thus, in the same kind of way, the square root and the square cancel each other out. So when we simplify this, or when we want to do the work there, we square root both sides, and we square root the entire left-hand side, the entire right-hand side. Now, the nice thing is here, there's only one thing here, and there's only one thing here, so it's easy to take the square root of those things. Okay? So the square root of a square cancels out, and it's just left with x. So we've kind of gotten the x by itself now. Okay? And then the square root of 121, Debbie was right, it's 11, but Mitch is also right, it's also negative 11 in this case. Okay? So, now, what's the difference? Why here, when we did the square root of 16, did I just say 4, and that is just the answer, it's just 4. But here in this equation, we have two answers, both positive 11 and negative 11.
Because I think because it just has...
There's something to do, yes, it has to do with the x in here. You're right, you're on the right track there, Alex. It's because in an equation setting, does someone want to describe it? I'll let Debbie, you want to give it a shot? Go ahead.
Okay, isn't it because that, like, no matter what you multiply, it's still going to equal the answer, so you can multiply x and negative x?
Right. When it comes to solving an equation, we want all the possible answers to the equation. Now, for 90% of your life, right, whenever you solved an equation, you always had how many answers? 1, right? But that's not the case. In fact, we maybe have trained you, and to always expect to only have one answer for an equation. But in this case, there are two answers. Why? Because if you take 11 and square it, you get 121. I'll show you here in the calculator. 11 squared is 121. Negative 11 squared is also 121. Because, right, a negative times a negative is a positive, so you get positive 11, okay? So, we have two answers here. But here, when I just have plain old square root of 16, the answer will be 4, okay? And the reason for that is because this is not an equation, okay? This is just kind of like an expression, right? There's no x's to solve for here. This is just saying, what's the square root of 16? Well, it's 4. 4 times 4 gives you 16. But here, this is saying solve for x, so we want to find all the x values that make this equation true. Well, both 11 and negative 11 make that equation true. So that's why we have two answers here and only one answer here for 4. Okay? So, expression, one answer, the positive root. Equation, two answers, the positive and negative version, okay, of those numbers. Okay? Yep, question. Okay, so negative inside the square roots actually are, possible, but in general, right, we don't worry about those. Yes, you can have negative square root, but not square root of a negative. And the idea is that that's imaginary as square root of a negative number. And have you guys seen imaginary numbers yet? With I? No. Okay, you'll look at I think you'll see those in algebra 2 maybe, but there's imaginary numbers. So we keep it real. I know, right? Well, I know it's kind of weird. But when you take the square root of a negative number, yes, it's imaginary. Okay. Anywho, so there's that. What about, though, what about the square root of 50? What does that equal? Yeah, it's a decimal, right? If I try and type that in my calculator here, second square root of 50, okay, it gives me a decimal here. And so, and by the way, this kind of decimal, okay, it will never repeat. All right, and it doesn't end. It goes on forever. So this number, square root of 50, is called an irrational number because it goes on forever and the decimal never repeats. Right? The decimal, for example, if we have like 1/3, okay, the decimal goes on forever, but it repeats. Right? So we can write this number here, this decimal can be written as a fraction of 1/3. 1/7, believe it or not, this mess of numbers, it does repeat, right? 142,857, 142,859. The calculator's rounding it up, though. It should be 1.142857, so on and so forth. So that repeats too, okay? Square root of 50, though, that number does not ever repeat regularly, I'll say. I mean, you might, it's like there's a 7, Mr. Witt, and there's a 7. Well, yeah, that's repeating, but I mean, it won't repeat in the way that like 0.33333 repeats or 1/7 repeats. It never actually repeats in a regular fashion like that. So it's called an irrational number. Can you guys think of any other numbers that are irrational? 89? No, 89. Oh, square root of 89. Square root of 89 would work. Square root of 42 would work, yeah. All the square roots. It's a famous Greek letter, too. Yeah, pi. Pi, right, is irrational as well. Pi is irrational as well. Anyway. So, but mathematicians, right, we're like, we want to be able to maybe try and do something with this, though, because there actually is some work we can do here, and this is what we can do. 50 is equal to 25 times 2, isn't it? Okay. Now, why did I pick 25 times 2 here? Why didn't I pick something like 5 times 10? 5 times 10 is 50. 25 is a perfect square, right? So, what we can do then, because this is multiplication, okay, the square root of a product, you can break up a product like this. Okay? Square root of 50 is the same thing as square root of 25 times 2, which is the same thing as the square root of 25 times the square root of 2. Now, why is this helpful? Well, Josh, what's the square root of 25? That's right, it's 5. Okay, Josh, you might want to pay attention. Okay, you might want to pay attention. Okay, it's 5 times the square root of 2. Okay, 5 times the square root of 2. Now, can the square root of 2 be broken down into any more perfect squares? 1, but then it's just going to be, I mean, if I continue with that, it'll be the square root of 2 times 1, which is equal to 5 times the square root of 2 times the square root of 1, and it'll just be square root of 1 is 1, and so it's still just going to be 5 times the square root of 2. So while, yes, we can divide it by 1, it's not going to really help us. It still ends up being a 5 times the square root of 2. So that's the final answer right here. This is the simplified version of the square root of 50. And let me show you that that's the same thing. There's the square root of 50's decimal, 5 square root of 2, and there's 5 square root of 2 decimal. Are you convinced they're the same thing?
Yes.
You believe me? Debbie's convinced. Eli says no. Mr. Wood's a liar. All right, let's try another one. Right, exactly. Nice calculator. Okay. All right, listen up here. Next one. Square root of 18. Okay? Again, square root of 18. I'll get 1 second, Josh. Square root of 18. We could break that up into like 3 times 6, right? 18 is 3 times 6. But 3 and 6 are not perfect squares, so we don't want to use 3 and 6. But what perfect square can we divide 18 by? 9. The square root of 18 is 9 times 2. All right, folks. Square root of 18 is 9 times 2.
Wait, so I have a quick question.
All right, hold on a second. Let me finish this, please. Okay. So square root of 18 is the square root of 9 times 2, which we can then break up that product, square root of 9 times the square root of 2, which gives us then 3, right? Square root of 9 is 3 times the square root of 2. Can we break 2 down any further?
Yes, but no.
Right, yes, but no, right? 2, we can't divide that by any more perfect squares except for 1, and 1 won't really help us. So that's our final answer. Okay, Josh, you had a question, and then Eli.
I was gonna, because he doesn't think I know what I'm doing.
Okay, you were going to do it. You were going to do it.
Face one, just do the next one.
The next one, you got it. Okay, Eli, what was your question?
I'm gonna get all of it.
Okay, so what exactly is the perfect square? Because I'm not getting it.
Those.
Well, yeah, but what does that mean?
What does it mean? So think about a square, right? Okay, so a square, right, has the same sides, right? Same sides, all the same length. And so when you find the area of that square, for example, okay, what are you doing? You're taking the one side and multiplying it by itself, essentially, to find the area of that square. Okay, so when you raise something to the second power, that's also called squaring it, right? So then the perfect squares are numbers numbers that you can get by squaring another number. Okay, so for example, 4 is a perfect square. So 4 is a perfect square because you get it from 2 times 2, 2 squared. Okay? 100 is a perfect square because you get it from 10 times 10, 10 squared is 100. Is that making sense then? Okay. So you just look for perfect squares you can divide your numbers by. Okay? So, Josh, 300. No, it's not that bad. Look what you got up here. Do you see any perfect squares up here that divide it evenly?
Oh, wait, you do 10?
10 squared is 100. Well, you can divide it by 100, right? So it's 3 times 100, right? Okay? Which you can break that up then. Square root of 3 times the square root of 100. Okay? The square root of 100 is what, Josh? Well, look up here. 100. You get from, can you see the 100 up there?
Yeah.
It's, how do you get 100? From doing, what do you square? 10.
Oh,
So the square root of 100 is 10. Okay? So this is equal to the square root of 3 times 10.
That might have been the purpose of the warm-up, huh, to have them right in front of
That
you.
might have been the purpose of the warm-up, Miss Bachman. You got it. It's like I was thinking ahead. Okay, so typically, though, we don't write the whole number here at the end. We rewrite it in order whole number times the square root. Okay, and the part of the reason why we write the whole number first and then the square root after it is because if you have it in the other direction, sometimes people might get confused about whether the 10 is under the square root or not. Okay, so there's our answer. Jordan, out.
Come on.
Okay.
Get water and come back in. Go get water.
Okay. All right. Let's try another one here. Okay. All right, let's go to... Oh, Gabe's not here. Mitchell! Square root of 80, Mitchell. What perfect square can we divide 80 by?
20 and 4, right?
20 and 4. Okay, perfect. So, 80 is the product of 4 times 20. Okay, and so we break that up. Square root of 4 times the square root of 20. Okay, Mitch, what's the square root of 4?
2.
It's 2. Now, in these previous problems, after we pulled out that perfect square, we couldn't simplify square root of 3 anymore, right? 3 did not divide by any more perfect squares. 2 did not divide by any more perfect squares except for 1. Okay, but 20, Mitch, can we divide 20 by another perfect square?
4 and 5.
Another 4, right. So if we then rewrite this as square root of 4 times the square root of 5, oops, do it this way. Okay, we again can break it up, so it's 2 times the square root of 4 times the square root of 5. Okay. And what's the square root of 4? It's 2, so it's 2 times 2 times the square root of 5. Right, and so since we have these two numbers here, 2 times 2, we can go ahead and multiply this together. They're two whole numbers, so it's 4 times the square root of 5. And that's our final answer. Okay, so you'll see here that sometimes, right, after we pull out one perfect square, we see that there's still another perfect square that we can factor out, right? That 20 could break down into a square root of, or 4 times 5, which is another perfect square there. And so our final answer here is 4 times the square root of 5. Okay, so Debbie brings up a good point here, okay? She saw that 80, while Mitch was right, it's 4 times 20, it's also is equal to 16 times 5. And the square root of 16 is 4. And 5 we can't divide anymore, and so you can also get it that way as well. Okay? All right? So 2 different ways to do it. 2 different ways to do it. Questions on any of that? Excuse me. Okay, so why don't you guys try these two here? All right. So try square root of 98. Actually, I'm going to have you try 3. Square root of 75 and the square root of 120. Okay? Okay? So try those 3. Try those 3. And I'll kind of come around and help as necessary. Again, use your list of perfect squares to help you out. Okay? You can just guess and check. 98. Can we divide 98 by 4? No, it doesn't divide evenly. Can you divide 98 by 16? No, it doesn't divide evenly. Keep going. Keep going.
Alright.
One of those, I'm telling you right now, you can simplify.
What did you do? What? Here, do that to me. Come on. 98. What are you going to do? Yeah. You can always just do it like that. So then write it down. You want to do
I'm going to try here. What does it simplify to me?
Okay, so then it's going to simplify down to this. Okay, so look at when you broke up 80, you wrote it square root of 16, square root of 5, right?
Yes.
The square root of 2,
What is
the square root of 49, right? And then times square root of 49.
I don't know why you're telling me this.
Yeah. Feel like put that little right there. Times square root of 49. Square root. Wait. It's just like that, but let's do it so you know. We have a good note in our notebook, okay? So 49 equals the square root of 2 times the square root of 98.
So look for perfect squares that divide 98.
Okay, now did you do the warm-up? Make sure you get these written down. So is 2 up there at all? Yeah. Huh? Yes. There isn't a 2 though. Okay, is 49 up there at all? And that's what? Alright, so then you can break down 49 as what? Plain old, just 7. That's 7. The square root of 49 equals 7, right? So what will your final answer, since this doesn't break down any farther, what are you going to write? It all equals...
You gotta finish your test.
Yeah. So if this doesn't have the square root, it goes on outside. And since we can't break it down anymore, right?
Okay, like 1 more minute here or so.
Keep it the same. So you're going to write it equals 7.
I just woke up from my study, death, and resurrection.
So, that's
Welcome back
75. What can
to the
you
land of the
put
living.
75 down? First off, look, is 75 up there? No. We need to do like
75
start
would
out.
be not there.
So it's not by 2. This ends in 5. 75 by 5. Let's do it. What do you get? 75 divided by 5.
So did you
Gives you 15, right? So write down your 75 here. And it equals... No. Oh, yeah. No, you're right. Yeah.
81, so you could, okay, so if you
Done
put your
that.
98 divided by
That's up there
81,
too. Sorry.
it doesn't divide evenly.
Okay.
So you don't take 8, so we can go
Then
down.
it
Your price would be
equals
4.
square root of 5.
98 divided by 4.
Good.
Nope.
Times
98 divided by
square root of 15. Okay, now we gotta look up there. Is 5 or 15 up there at all? No. Can 5 be broken down by any other number besides 1?
You can break it up like that.
Like 5 divided by 4 is not 5 divided by 3 is not, 5 divided by 2 is not, 'cause it's not even. So 5 is done. But what can 15 be broken down by? 15 divided by 5 is 3, right? So, to keep this up straight, what I do is I circle what can't be broken down anymore, so you're not, because these will get lost after a while. So now 15 is going to work equal to the square root of 5 and the square root of 3, right? Because that's what we multiply by.
All right, folks. Here we go.
Put your square root signs, because they're not perfect squares, right? And then we'll go over that.
Here we go. Let's take a look here and see what we're able to come up with. All right, so Piper. What'd you say, Piper? Okay, so 98 is 49 times 2, and then we can say that's equal to square root of 49 times the square root of 2. If you want to skip this step, by the way, folks, if you want to go straight from square root of 98 is square root of 49 times square root of 2, you may do that. You can skip right down to there. All right, anyway, and then Piper, how does this simplify? 7 times square root of 2, exactly right. And that's as far as you can go because 2 doesn't divide anymore by a perfect square. Thank you, Piper. Very good. You can just put next to each other. That's because it's implied when you write something next to each other in math, right, that they're multiplying. All right. Antoinette. Next one, please. How does that simplify? Okay, square root of 25 times the square root of 3. Good. 5 5 times the square root of 3, or 5 square roots of 3. Okay, which again, you don't need the multiplication symbol, it's implied when it's written there. Alright, very good, Antoinette. Well done. Let's go to Jordan. Square root of 120 there, Jordan. How does that simplify?
12.
It is 12 times 10, but are 12 or 10 perfect squares?
I'm tired. I can't think now.
Okay, we can go to someone else.
I can do this.
Well, Jordan, I don't want to wait. I want to dilly-dally. So we'll come back to you another time, okay? Try and do the problem when I asked you to do it, though, please. BJ, did you get square root of 100? Oh, where'd he go? Bathroom. He's coming in. I'm sure he doesn't have the answer there. He's not in the bathroom. All right, Josh, please. Square root of 120. Were you able to simplify that one? Well, I want you to figure it out now. I want you to tell me, do you have it? Looks like no. All right, Donovan, I saw your hand in the air. You don't have square root of 120? All right, Kwanye, please. Say again?
You said, is it 2 or 3? 2 and 30. 2 and 30.
2. Oh, okay. So, yes, I think you're one step ahead of me, though. So 120 is the square root of 4 times the square root of 30. And then, yes, the square root of 4 simplifies to 2 square roots of 30, yes. Yes, you can break 120 down to 2 and 60, but the problem is that neither 2 nor 60 are perfect squares. The idea here, for the square roots, Josh, we want to limit ourselves to numbers that are only perfect squares. That's why... Guys, I don't know what you guys ate, like extra sugar in your cereal this morning or something like that, but some of you guys are really moving your mouth a lot.
It doesn't mean keep talking, like you should be talking.
Exactly, though. I don't think you guys are getting the hint. I want you to stop talking. We're going over the notes, okay? Now, we can be silly and stuff like that in class and have fun up to a certain point, though, because the purpose of this class is not to laugh and have fun. The purpose is to learn geometry. Now, if we can do both at the same time, that's great. But right now, we're having too much fun and not enough learning, okay? So please, let's get back on track here, okay? So, anyway, when you are simplifying these, you're looking for perfect squares, okay? And only perfect squares. If you can break it up into other products, that's great. But if they're not perfect squares, it's not helpful because we're trying to simplify square roots. All right. So, there's perfect square stuff. Now, how are we going to be using this? Because that's only half of what we're learning today. We're also going to be talking about Pythagorean Theorem, okay? So let me get into that. All right. Okay? The Pythagorean Theorem is named after a Greek mathematician named Pythagoras. Okay, so that's why it's such a weird name. It's a Greek name. Okay, so Pythagoras is just it might have a meaning. I don't know, but all right. Given a right triangle. So notice that's important, right? This does not work for an obtuse triangle. This does not work for an acute triangle. This only works for a right triangle, okay? So don't try to start applying this to any triangle you see. It only works if your triangle is a right triangle. What makes a right triangle a right triangle? It has a 90-degree angle, that's right. Okay, so given a right triangle with legs, remember the legs of the right triangle are the two sides that touch the right angle. So given a right triangle with legs of length, and we'll say, I gotta zoom out just a skosh here. Of length, never mind, I'm just gonna do it this way. A and B. Okay, so given a right triangle with legs of length A and B, and hypotenuse, okay, of length C. Okay, then A squared plus B squared is equal to C squared. Or in other words, leg squared plus leg squared is equal to hypotenuse squared.
We saw it like that before.
Okay? That's Pythagorean theorem, okay? So some of you guys maybe just remember the a squared plus b squared equals c squared part, but you don't remember that certain things go into that a, b, and c. Right, I'll draw a quick picture here of a right triangle to help you out as well.
Would it also be side squared plus side squared equals angle squared?
No,
No.
there's no angles in this one.
It's a right angle.
Right, but they're not in the formula, I mean. Okay? So, leg, hypotenuse. Okay? Since this side's the hypotenuse, that's got to be our C. These two legs, though, it doesn't matter which one you call A, which one you call B. Does not matter. Your choice. Okay? Does not matter. Your choice. So you can say that's A, that's B, or that's A, that's B. Doesn't matter. But hypotenuse must be C. Hypotenuse must go in for the C there. Okay? And a little fact there, the hypotenuse is always the longest side. Okay? Hypotenuse is always the longest side of a right triangle.
So is it the one that connects the legs together?
Yep.
Okay.
It's always opposite the right angle too. Okay? So hypotenuse is always the longest side of a right triangle, and it's always opposite the right angle, right? We've talked about that before, though. All right. So questions on any of that? You guys have hopefully seen that before. That should not really be new information to you, I don't think. All right, so let's see this in action then. So, let's find the missing side. Okay, we're going to find the missing side of our triangle here. Okay, so here's our first triangle. Okay, it's a right triangle. Okay. So, I see a coin here. Hang on, though. So, Dorian, all right, we have our right triangle right here, Dorian, right? Okay. We are missing this side. So, this side, is that a hypotenuse, or is it one of our legs that we're missing here? That's right. It's opposite the right angle. Okay, so we're missing the hypotenuse, which means we're missing the C of our Pythagorean theorem. So I'm gonna go ahead and just call this C here. And then as far as the 4 or the 3 are concerned, right, we can call either of those A or B. So I'm just going to call the 4, actually, what do you want to say, Dorian? Which one do you want 4 to be, A or B? A, okay. And then 3 is B. Okay. And so we set up our Pythagorean theorem. A squared plus B squared equals C squared. So we plug in. 4 goes in for the A, so it's going to be 4 squared, plus 3 goes in for B, 3 squared, equals C. We don't know the C, so let's leave it C squared. Okay? So now, Dorian, what can we do to simplify this? So, for example, what's 4 squared? 16, yeah. And what's 3 squared? 9, yeah, you got it. And again, equals C squared. Okay? And then we can add 16 and 9 together, can't we there, Dorian? 25, very good. Okay? So now, what do we need to do, Dorian? We don't want to know, we know what C squared is 25, but I want to know C squared, I want to know C. So square root, exactly right, square root both sides. And now you can see why we just talked about square roots, because when we solve these Pythagorean theorem problems, we're going to have some square roots show up. What is the square root of 25, Dorian? 5. Okay? Now, some of you might look at me, or might be thinking to yourself, Mr. Widmeyer, but you just said when we're in an equation setting, when we're in an equation, right back here at the previous notes, I got you, thank you. Back in the previous notes, when we had x squared equals 121, if you square root both sides, you told us that the answer should be 11 and negative 11. Why don't we have 5 and negative 5 in this situation? It's an equation.
The length can't be an angle.
Yes, it doesn't make sense to have a negative 5 hypotenuse, right? This is supposed to be an actual triangle. Triangles don't have negative hypotenuses, okay? So we wouldn't count that as negative. So we ignore the negative, we only keep the positive 5. Okay, exactly right. Okay, questions on any of that? We're all good there? All right, we're going to try one more here at least, I think. Let me see. Let's try another one. Let's try another one. Okay, we're going to find the missing side. All right, let's see. I'll draw another right triangle. Bless you, it's not drawn to scale. So. All right, let's see. Let's say this is 24, this is 25. Okay. So again, we want to find the missing side. Hang on, I'm going to call on someone, Jordan. Thank you, though. Right, let me give someone else a shot here. We might come to you if we need help. Okay. So again, we have a right triangle. We're going to solve for the missing side here. So we're going to use a squared plus b squared equals c squared. All right. So BJ, this 24 here, where can I plug that into my Pythagorean theorem here? Into A? Yep, we can plug it in for A. Or we could have plugged it in for B, either one. Okay? The 25, where is that going to go? Yeah, it's got to go in for C. Okay? So it's the hypotenuse. It's opposite the right angle, so that always goes in for C squared. And so then we're missing one of our other legs. We'll call that one B. Okay? Now, 24 squared, I don't have that perfect square up there, but I think it's 576. 576. Thank you. Plus b squared. And then 25 squared is 625, I think. Yep. Okay, so we square those quantities. And then BJ, what's our next step here? To continue solving for b squared, we want to get that b squared by itself. So what should we do to both sides here? Well, what's with the b squared that we need to get rid of? Say again? Okay, so eventually we want to get b by itself. We want to get rid of the square, but let's get rid of this 576. What can we do to that? Subtract 576 from both sides first. Yes. Okay, so b squared equals 49. Okay, and then BJ, last step. You want to do the square root. So it's b squared is 49. I want to get rid of this square, so we have to do this little square root symbol. Okay, and we know from our list up here, 49. Okay, that is 7 squared. So that means the square root of 49 is just plain old 7. Okay, plain old 7. Okay? All right, we're going to do one more here, and then I'll get you guys started on your assignment. Okay? Last one. Last one. I don't really know why there's talking right now because I didn't say we're done, okay? Bell's not going to ring anytime soon. You need to be paying attention. We got one more problem here, okay? Listen up, please. Okay, we are not done. Okay. Last one here, though. We're going to do this one. Last one. Together. And then we'll have you guys run your assignments. Do you find this difficult?
No.
Okay. All right, column W. Again, it's a right triangle. We have two sides, so we're going to use Pythagorean theorem here. Whoops. Messed that up. Bless you. Okay. So the 4 here, column W, where can I put that 4? Yep, A or doesn't matter, so we'll put it in for A. Yep, 4 squared plus the 6 here. Where does that got to go? Yes, good. It's got to go in for C. It's the hypotenuse. It's opposite the right angle there, so it must go in for C. And that leaves then this side as our B. We don't know that one. Okay. So 4 squared is 16, B squared, and then 6 squared is 36. Okay? Column, what should I do from this next step? Column W, still, sorry. Not yet. We want to get the B squared by itself. We still have this 16 we got to deal with, so subtract 16 from both sides. So we get 36 minus 16, which is 20. Now, we want to square root both sides here. Yeah, if we square root 20, it is not a perfect square. So we stop and say that just B is equal to the square root of 20. We could stop there. Technically, that's correct, but we're going to simplify this because we know how. 20 can be divided by a perfect square. What perfect square divides 20? 4 does. So this is equal to the square root of 4 times the square root of 5. And then the square root of 4 is 2 square roots of 5. And that is our final answer there.
Did you do the same thing with this A? Like you didn't have A?
Yep, it'll work the same way. Yep. Questions on any of that?
So, okay, so let's go on the test.
All right, listen up, please. We have a question. Hang on. Listen up, please.
Okay, let's say on the test it was that, and we only did,
Just down to here.
yeah, and we didn't simplify things.
If the directions specified, simplify all square roots, you'd lose a point. You wouldn't get full credit. If the directions didn't specify, simplify all square roots, then you still get full credit. You're supposed to do. Okay. So, yeah, I would still recommend you simplify all of them just for the practice of it because you're going to be using it later. I'll tell you that much. Okay.